So, what I'm going to start with then, obviously when you have an LED, there's a particular forward voltage on the LED, and we need to put the right amount of voltage across it and the right amount of current in through it. So in order to do that, we use what's called an LED current limit resistor. I'm just going to show you how they're worked out, but don't worry, if you don't want to do the maths, then we do have a little option for allowing you to do that on the computer and let it sort the maths out for you. So what we do then, we have a resistor and we have an LED. Now typically an LED might have a forward voltage of, let's say, 2 volts to keep the maths simple, and that is called VLED. And then across a particular supply, we're going to have some voltage across the LED, and we need to get rid of the rest of the voltage across the resistor. I don't know whether we might be able to zoom in just a little bit, just so that we can see the writing on that. So we've got V resistor there and VLED there. Now obviously, if the total voltage is V bat is across that, then that is made up of the V resistor plus the voltage on the LED. So 5 volt supply, let's say V bat is 5 volts. The voltage across the LED, we've looked up on the data sheet, and that one is 2 volts. Therefore, the voltage across the resistor needs to be 3 volts, so that the 3 volts plus the 2 volts gives us the 5 volts. What we can then do is we can apply a little bit of Ohm's law to that, and we need to know how much current I we want, and obviously the current going through the resistor is the same as the current going through the LED. And the data sheet will say typical current might be 10 milliamps, maximum current 20 milliamps for a given LED. So in this case, if we say the current going through the LED is equal to 10 milliamps, or 0.01 of an amp, which is obviously the same thing, then we can apply Ohm's law to this, and we can work out what the value of the resistor wants to be. So resistance is given by the voltage over the current. That's come from Ohm's law, and if we put those numbers in, we've got the voltage of the resistor, Vres, at 3 volts, and we've got the current going through the LED at 0.01 volts, so we want something around a 300 ohm resistor in that case. So, so that's how the maths is worked out. If you don't want to do that yourself, then you can go and use, we have an LED resistor calculator. On all the product pages that have got an LED on them, there will be this resistor calculator. You plug in the battery voltage, it already knows what LED you want it to be, and you just click calculate, and it will also tell you what the resistor colour bands are that you need to go with that. One of the other questions that we get asked from time to time is to do with connecting multiple LEDs together, and there's various ways of doing this. I'm just going to start with the simple option. If we're doing colour changing LEDs, then we don't need a current limit resistor on a colour changing LED. So if we've got 5 volts here, and they'll work from about 2.5 volts up to about just over 5 volts. If we've got 5 volts there, then it's simply a case of just connecting in the LED into the onto the parallel. If we want to put an extra LED on, we just connect that one in parallel like that, and we can keep adding as many of those into the circuit as we like. So colour changing LEDs, really quite straightforward, no worries on those. There's for normal LEDs, we can do 2 different connections. We can either do a series connection, or we can do a parallel connection. So suppose we had 3 white LEDs and we wanted to do a series connection on the LEDs. We can share one current limit resistor, and we can put a number of LEDs off the same supply like that. Now, suppose on each of these that we've got 3.3 volts dropped across each LED. Then across the 3 LEDs, give or take to the nearest 0.1 of a volt, we've got 10 volts across that, so 3.3, 3.3 and 3.3, which leaves us with a couple of volts there. And again, we can do the same maths and we can work that out. Now, the benefit with using the series connection is that the current I going through that LED and that LED and that LED is always going to be the same. So all of those LEDs are going to come out at the same brightness. So that's probably the best way of connecting it up, but you'll notice that we've got a 12-volt supply there, and it's not always practical to have such a high supply voltage. So if we wanted to do that same circuit, but as a parallel connection, what we'd need to do is, in theory, the best way of doing it is to supply one current limit resistor for each of those LEDs. Like that, and we can work out what the current limit resistor wants to be, again using the same logic. If that's 3.3 and we want 5 volts across there, then we're going to have 1.7 across there, and we can do the maths again. Now the problem with this is that obviously we've got one current limit resistor for each LED. Now that will give you exactly the right brightness on each of those LEDs, but you do need a separate current limit resistor. So what a lot of people choose to do, and this, it does work fine, but it's not necessarily the best practice way of doing it. But it is perfectly good if all the LEDs you're doing are the same and they've come out of the same bag, so they've been made in the same batch. You can connect all those together and just put the one current limit resistor in. Now the maths gets a little bit more tricky here, given the current going into each of these. If that's I LED, then that is going to be 3 times I LED. Now the problem with this then is that we're relying on exactly the same amount of current going through each of these LEDs, and if they are all the same, then they will end up with approximately the same amount going through each LED, and that will work out fine. So that's why I'm saying it's important to make sure that they are the same. And then we can do the same maths again. If we've got 3.3 volts there, we've got 1.7 volts there, and the current there, if it was going to be 10 milliamps, it's now 30 milliamps, and we can do the maths. Now, like I say, if you're just wanting a single LED with a resistor, or if you want to use this configuration, go onto any of our LED pages, and there is an LED calculator on each of those that explains how to do that. So coming up in just a moment, Kevin is going to be doing a demonstration on different amplifier kits. Don't forget, if you have missed anything during today's show, you can watch again, and watch again will be available next week. If you do want a sample of anything, particularly the amplifier kits that Kevin's going to be demonstrating in a minute, then you can have a free sample if you're a teacher at school and it is a Kitronic project kit. There is a couple of exceptions. The really high power amplifier that Kevin's about to demonstrate is a little bit too expensive for us to send out as a free sample, so unfortunately we wouldn't do one of those, but anything else we would do. So as well as the LED calculator, which you can find on the product pages and also in our resource section, we do have some other resources. There's tutorials there, there's data sheets there, and there's also an interactive learn and test zone which allows people to learn about a topic and take a multiple choice question.